Okay, so tonight we are starting our statistics section of this module, or as some people call it, statistics. It is actually not that bad, I promise. Especially this first section, descriptives, is really the complete basics and the foundation. So it's very important to understand these basics before we get into the inferential statistics. Okay. It's like understanding the basics of algebra before you try to do trigonometry. It's really important. Okay. And I should know, I was terrible at algebra at school, so trig was not fun. Particularly what we're covering tonight was covered in up to what would be matric core maths. So it would be a refresher for those of you that did do core maths. That's whatever, we're going to start completely from scratch so everyone will understand anyway. Okay. And yeah, just again, it's a mindset thing. So try to just remove the maths from it. Like, yes, there are numbers involved, but it's really at this point more about just understanding what data means. And in terms of research, that's often just much more interesting than the maths. Because at the end of the day, you're at the end of this section, you're going to learn to understand how to interpret the statistics in like a research paper. And it's more than likely what you're going to have to do in your exam will be to interpret statistics. I don't know for absolute certain. You may have to calculate a few things, but so we will obviously go through that as we go along, and I will teach you how to do that. But yeah, it's absolute, like the most important thing is that you know how to interpret them. Okay. You'd be able to tell what they mean. So yeah, we're gonna just I'm gonna go through the key concepts of descriptive statistics, and then we are going to do the activity together. I did ask you to try and complete it before this evening, which is cool, because then you'll have more of an idea of what's going on, but we'll work through them quickly together to give everyone the answers, basically, and you'll see where you've gone wrong if you go wrong. And then, as always, questions. Okay, are we good to go? Anything bothering anyone before we start? Right. Okay, so what are descriptive statistics? Very much as it says, they are statistics that describe the data. It involves summarizing, organizing, and presenting the data in a way that we can meaningfully and concisely understand what it means. So there's a lot of graphical representation that I think we'll spend a whole session on, graphs and how to interpret them later on. But for now, it's really just these basic things that we're going to be talking about are the distribution of data, measures of central tendency, and variability. Okay, I'm going to break these all down into their smallest parts so we can understand. But the idea is that descriptive statistics just is to provide you with an overview so that you can see what's going on with the set of data. Okay. Opposite to that, well, not opposite, but building on are inferential statistics, which we will get to. And that is what you use to make inferences about the data. That is what you use to test hypotheses. Okay, there's specific tests that you use, but we will get there. Tonight, it is all about describing and understanding. Okay, so let's talk about distribution. When we talk about distribution, what we mean is the way that data is spread out, or the way that it is organized, And this is really important for us to understand, because the whole point of gathering data and research is to kind of understand a situation that's going on, right? So if we just use an example, say I'm taking first year varsity college psychology students exam results, and I want to see how they did. Now we run a whole bunch of descriptive statistics on that. We can calculate the mean, we can see what the average score was, say for psychology 1, whatever. We can find out the mode, so what was the most commonly achieved score. We can find out the median. Don't worry to be scribbling this down, we're getting there. What was the kind of mid-range? We can find out the range, and we can do all of this stuff, and we can represent it graphically, which is fantastic, particularly for people like me who are afraid of numbers and much prefer pictures. So we talk about distribution. There are different ways that we talk about distribution. We've got normal distribution. So if you look at this little picture at the bottom here, the top left would be a normal distribution. What that means basically is that the mean, or the average, sits in the middle of the data range. And that, remember, that's not always the case. The mean doesn't mean the middle, the mean means the average. Okay, so in a normal distribution, it would be in the middle, and you have a nice kind of could be a curve going up and down. These are bar graphs, but same story. If it were a line graph, it would be a nice bell curve representing a normal distribution of data. Okay, so just imagine there are numbers at the bottom here, like from 0 to 10, okay, and then normally distributed. You can also have a uniform data set, which means that a lot of the answers are the same. So this happens when you have many modes in a data set. So you have many commonly occurring numbers. Okay, and then you can also have skewed left or skewed right data. This is when, and I know it's weird that it says skewed left, but then the highest one is on the right, but that's, remember, what it means is that the data is skewed to the left-hand side of what is the mean. So in this case, you can infer that the mean is here at the end. The mean would be the kind of higher, and the most of the data sits on the left-hand side of the mean, and then skewed right is the other way. But we will get into this again with the graphs now in a later slide. But that is the idea of distribution. It is seeing how spread out a data set is. And this can look quite interesting, because if you think about test scores, for instance, obviously it happens where people score 0 or 10%, but most of the time you're going to have scores sitting hopefully between the 50 and 90 mark, right? So you can imagine that that wouldn't necessarily be a super normally distributed line, because you're going to generally have higher bunches of data gathered around a different point. But again, it all depends on what the mean is. So let us get into that. Okay, so measures of central tendency. There are these three main things, the three M's of central tendency. And why it's called central tendency, this could be a way for you to remember what these things are, is that it's all about the mean. It's all about what the central focus of the data set is. Okay. So yeah, it just it helps you understand if your data tends to cluster around a point and what that point is, and we understand different things from there. Okay, let's get into each of them individually. Okay, so how do we calculate the mean? So the mean has this scary looking formula and is often denoted by X with a line on top. Okay, that just means the average of something. Okay, and simply what the mean is you add up every data point that there is and divide it by the number of data points that there are. So in this example on the screen at the top, let's say we had 6 students taking a quiz out of 10, and these are each of their results. Someone got 2, 6, 7, 8, 9, and 10, right, individually. So that means that n, which simply just means the number of data points, in this case, the number of test scores, equals 6. Okay, so this funny looking E is sigma. It's a Greek letter. Sigma, it means the sum of, which means adding up, the adding up of x. And in this case, x generally is signified by the value of the data set. Okay, so what happens is we've got mean equals, okay, so that's like x line with it equals, and then this is what the sum of x looks like, because we've got each data point being added together and then divided by n, which is 6. Okay, and then you do the maths, you have a nice little fraction, and your calculator spits out, in this case, 7. So that tells you that the average score in this situation is 7. Okay, are we understanding mean or average? Good, everyone else good? Fantastic. Okay, let's talk about the mode. Okay, so the mode is just the number, the value of the data that comes up the most frequently. So in a data set, you can have no mode. Like in that the example we just did, there was no mode because no number was repeated even once. You can have one mode, you can have two modes, you can have even more than 2 modes. And that just gives you clues as to the distribution of your data, basically. So yeah, just in these examples on the screen here, like you can see in one mode, so they've arranged their data very imaginatively, 1, 2, 3, 5. So the example, there is one mode, and what the mode is in this particular example is 1. Okay. In the second example, where there are 2 modes, because the number 1 and the number 3 appear the most commonly, and it's the same amount, right? So they both appear 3 times. So there are 2 modes, which are 1 and 3. Okay, are we understanding? It's literally simply just the number that appears the most times. And the thing is, how you find this more easily in a data set is you arrange it like they have, ascending. So generally in a test or an exam, if someone's trying to make you do this, they'll give you the data in a funny order, so that you practice putting it into ascending order, which we will do now with the activity. Yes, you can have multiple modes. Yeah, I think you would do it. You would have done it in Mathlet. I do believe so. It did appear there. I'm not sure to what extent, but yeah. Yeah, Jamie, so if it's in the middle, that means it's normally distributed. In other words, it's not skew. Good question, though. Good question. And we're going to get to skewness again in a second. Okay, let's just talk about the median. So the median literally just means the number in the middle of the data. So this is when arranging it in ascending order becomes very important, because obviously if you don't arrange it, you can't find the one in the middle, because the middle will be different. Okay, so there are just 2 ways to do this. Obviously you do it manually, kind of how everyone did it in maths, is you arrange all the numbers on a line and then you cross each one off from the end until you get to the middle. And yeah, but there is a little formula for it that helps. And so obviously if you have an odd number, if n is an odd number, so if you have 7 data points, you know that the 4th one is the median, because the 4th digit is the middle of 7 digits, right? There are 3 on either side of it. But if it's even, what it is the average between the two middle values. So if you have 8 data points, the numbers that are in positions 4 and 5, you need to get the average of those two. And that is what the median is. Okay. And average is those two divided by 2. Okay. Does this make sense? Do I need to like work out an example, or are we on the same page of the median? Because I mean, we're going to work through examples now, so cool. We will work this through. I'm gonna put up a whiteboard and do all of it with the activity. Okay. I just wanted to get the explanation out the way. Okay, so is my data skewed? Yeah, and this is taken from your notes. So this is why I put this particularly here, because I wanted it to look the same. Because if you Google skewness of data, obviously there are just different pictures and it's confusing. So I wanted to use the one from your notes that you can study from to explain it to you. Okay, so skewness is simply just the tendency for scores to cluster at either side of the mean. Okay, so when you have symmetrical distribution or normal distribution, the mean, the median, and the mode are all lacquer on top of each other. In the middle, your data is normally distributed. And then you have a very nice bell curve graph. Everything is symmetrical and looks very nice to people who like symmetry. Okay? When you have something that is positively skewed or skewed to the left, yes, then it means that the mode and the median are on the left of the mean. They're lower than the mean. And that's what happens when you have skew data like this. Okay, because it just means that obviously lots more of the numbers are falling before the mean. So you get a skewed graph. You have less values on the other side of the mean. And it's just the inverse of that for a negative skew or a right skew. Okay, they fall on the right-hand side of the mean. This would be particularly sad in a test score situation because it would mean that the average is super low. And so it would mean that most of the class did horrifically, but like a few got the same amount that's high and that is above the middle, you know. So this is why we need inferential statistics above descriptive statistics, because they are all contextual. They're really just tools we use to understand a set of data. Okay, we're all good for skewness and those things. Can we move on to variability? And this is where the actual statistics comes into it. Well, the actual maths really comes into it. Okay. All right, so there are these three main things. There are other things, but what you need to know at this level are these three things that are measures of variability. We have the range, super easy to work out. It's just the highest number minus the smallest number. That's your range. Okay. We have the standard deviation. There's a whole process for that and an equation, and the same with the variance. Okay. So the whole point of the variability measures are to quantify the spread, dispersion, or the scatter of the data. So this is what helps us really plot those graphs, so we can see how the data is spread out from the mean. Okay, they show you how individual data points deviate from the central tendency, so from the mean, median, and mode. So for instance, if you're picturing in your mind that those bell curve graphs, if you have a high standard deviation, it means you're going to have a flatter curve. It'll be like a lower hill, right? Because it means that the data is more spread out. But if you have a lower standard deviation, you're going to have a higher bell curve because it means that there would be more data compressed or bunched together around the mean. Okay, this will start making more sense when we go into calculating it. Okay, so the variance just measures the average squared differences between each data point and the mean. So it just shows you how much the data varies from the mean. Okay, the variance and standard deviation are two sides of the same coin. They work together, they are calculated together, and they tell you not the same thing, but the two sides of the same thing that you need to know about the variability of the data. Okay, so how to calculate the average? Extremely easy, okay? You literally, and again, step one, most important step one, is to arrange the data from smallest to biggest number. And then you simply take the biggest number and you minus the littlest number from it, and that's your range. So in this example, it's 23 minus 16, you get 12. Okay. I'm sure that that is cool. Can we move on to the standard deviation and the variance? Excellent. Okay, so this is where the paper and the calculators come in. All right. So everyone, what you're going to need for the activity just now, you're going to need a piece of paper, a writing implement, your calculator. Okay. Because that is how I got to this, but digitally. So in your notes, it shows you how to work out the standard deviation and the variance kind of separately in two different tables. But to make your life easier, you just make one table, and then you have all of the values. Okay. So in your exam or activities or whatever, if you see that they need you to calculate the standard deviation, the first thing you do, step one, arrange your data from small to big, because you're going to have done that anyway to calculate the previous stuff, okay? And then you're going to draw this table. So you need X, which is the data points. So in this case, the data set, this is the data set here in the blue box. So arranging it, I was going to say asymmetrically, no, ascending from, it goes 10, 11, 12, 14, 22, 26. Okay, I just pulled these numbers out of the ether, so yeah, but that's just what this is, okay? And then your next column, so then you write it down, boom, in the first column, populated. And then what you do is you make a totals column, row at the bottom, and that's the sigma, it means the sum of, and then so you add all of them together, and then you have a total x, you have a sigma x. Because you will see in the equations for standard deviation, you need the sigma x here. Okay. The next column, you do the mean. And that will obviously be the same for each row because you have one mean in a data set. You have one average. So I worked it out. 10 plus 11 plus 12 plus 14 plus 22 plus 26 divided by 6 equals 15.8. You may check me if you don't believe me, but I did check it. And I just rounded it to one decimal point for ease in the table, okay? The next column. Are we all together? The next column, you do x squared. Okay, so those of you who are not like super fun with algebra, all this means is you take this number in the first column and you square it. So in your, or which also just means you times it by itself. Okay, but on your calculator, there is a button. There's an x squared button. So you put in the number, you go 10 squared equals 100. Okay, I realize you can't see me, but I just demonstrated that for my camera. Is everyone cool on how to do this on a scientific calculator? This is important. You would have done this at school, regardless of your stream. You would have had to find a square of something. Okay. Okay, cool. So then you just populate that column, and you will need the sigma of x squared for this equation as well. So you just work that out. You just add all these numbers together, and you pop it there at the bottom of the column. I haven't done the other totals because you don't need them. Okay. And then you will see another part. So this is part of the variance formula, is you need x minus the mean. Okay. So then you work that out in this next column. So you do the first column minus the second column, and then you populate that column. Can you see how we're really just doing step by step by step, and then eventually we're just going to plug these numbers into the formula, and it's going to make perfect sense. Okay, so that's just what I did. So 10 minus 15.8 is minus 5.8. Okay, it's important to put the negative, like negative numbers exist, okay? So make them negatives if they are negative. It all works out in the end, okay? 11 minus 15.8 is minus 4.8, and so on. Okay. Everyone clear on that column and how that column is worked out? I just want to make sure I'm not going too fast through this. Cool, 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 cool. Okay, and then the final column that you need is you simply square that. Okay, so you take what you just worked out and you square it. Okay, that's literally all you did. So minus 5.8 squared is apparently minus 33.64, and so on. Okay, and now we magically have everything we need to just plug this into the calculator. Should you be required to do this in an exam or in a test or something, an assignment, you should show each step of working it out manually, because you get marks for each step, right? So if you do it in one step and you somehow get it wrong, that means you could get like 0 out of 5 when you could have gotten 4 out of 5 for doing the steps correctly. Okay. So let's shoot over to the whiteboard and show you how to do this quickly. Okay, so first off, let's work out the standard deviation. So the formula for standard deviation is, oh, it's shaky, I'm so sorry, SD, okay, equals big square root of sigma x. Oh, and before you ask, you should get a formula sheet in the exam should you be required to work anything out. So you shouldn't need to memorize these formulas, but it wouldn't hurt you to just do that, okay? Sum x, oh my goodness, squared. Okay, so these are different things, okay, mathematically. And this is over n. And then this is all over n minus 1. Phew! Okay, so we know in the example that I've been using that n equals 6. Okay, so now we just need to go back to my table. I'm not going to, because that's a lot of flipping between screens. Okay, I'm just going to plug in the numbers. Don't run away, Cheryl. Okay. Because remember, we have the numbers that stand for these things now, okay? So we know from our table already what the sum of x squared is, because that is that total at the bottom of the column. So what it was 171. And then that's going to be minus the sum of x squared. Okay, so we worked out the sum of x. That was the first total. The sum of all of the data points was 95. Can someone just tell me, please, quickly what 95 squared is? Whip out your calculators. It's going to be a ridiculously large number. 902. Oh, guys. I think it's 9025. Okay, 9025. And that is over 6. Because n equals 6. Okay. And then it will all be over n minus 1, which is 6 minus 1. I think we can just do that in our heads, hey? 5. Okay. Now, again, you could just put this into your calculator. However, don't do that. Do the next step. Okay, break it down. So, we'll do this. What is this? Someone please tell me what 9025 divided by 6 is. Correct. 1504. Goodness gracious. Points. And yeah, let's just keep it to 2 points. It's more accurate for now. So it would be 17. Remember, because when you round up, if it's above 5, it goes up. Okay. Over 5. Okay. There's another step. Somebody please tell me what 1721 minus 1504.17 is. I trust you. 216.83. Okay, do the last step. What is that divided by 5? .3. Gonna round to 7. Okay.
Just a quick reminder here, guys, to carry the square root through. So we take the square root of 43.37, and we get 6.59. That is the standard deviation.
It is S squared for variance equals sigma x minus the mean, all squared, over n minus 1. All right. Let's go back to our table. So we know what this whole number is. So, okay, I'll believe you while someone's checking that. Okay. Oh no, why are you in bold? 68. Confirmed. Excellent. 0.2 divided by n minus 1, which is 5. Somebody do that real quick. Call it 62. And now we have the variance. Okay.
So, you should notice something cool here. The standard deviation is the square root of the variance. That is a neat trick to remember. Once you have worked out the standard deviation, you just square your answer to get the variance.
Everybody cool with how to work that out? Let me head back to my slideshow. So this is the graph I was referring to earlier. So this is what a normally distributed standard deviation graph looks like. So these numbers are standard. This is what it is. So in any data set, depending on where the mean falls, 68-ish% falls between minus or plus 1 standard deviation. Okay, ignore the stuff at the bottom with the mu and the onion, like whatever. You don't need to know that now. Okay, but the point is that that is how we arrive at this graph. Is that mathematically in a normally distributed data set, this is how it is spread out. Okay, which is all you need to know for now. Okay, are we ready to hit our activity? We probably only have time to go through the one, but it's literally the same thing. So knowing how to do it, you should arrive at the correct answers, and I can provide the answers to you guys. Okay, so we are going to draw our table. I'm probably going to do it badly, but it's fine. Okay. So what is the first step when you receive a data set? Oh, they've been so kind. They even gave it to you in ascending order. Magnificent. Okay, so the first question, calculate the mean, mode, and median. Okay, let's do it together. So everyone, should I write this out? Okay, what is 6? Oh my goodness. Great start. 6 plus 11 plus 17 plus, oh goodness, 23. Keeps it interesting, right? Plus 31 plus 46 plus, what's the next one? 79 plus 82 plus, goodness, could they not have been just giving you $5? But remember, in a real data set, you have like hundreds of numbers, but we use computers for that. 114. This is all just about learning about how it works. Okay, 13. Oh, good lord. Okay, how many numbers are there? What is n? 1, 2, 3, 4, 11. Okay, so anyone with a calculator? What is the mean of this data set? 58.27. Okay, just gonna let someone confirm that. Confirmed. Okay. 8, 7. Okay, excellent. Done. Okay, what's the next one? The mode. What is the mode? Is there a mode? Question, there is no mode. Okay, because they all appear once. Don't overthink it. It is simply there is no mode. Okay. What is the median? Okay, it's the middle number, and there are odd numbers, which is fantastic. So that means that it will be 2, 3, 4, 5 in the middle. Bloop. 46. Correct. Okay. Excellent. We have done the first question. Okay, let's calculate the range. So what is the range, guys? That would be, there's no like denotation for that really. Range equals 136 minus 6. Okay. 130. Oh, gracious. Sorry. 130. Okay. That is the range. Okay, now we get into the business, calculating the standard deviation. It's always worth checking that twice. Okay. So we're going to work out the standard deviation. Again, let's do our formula. It's of x squared minus x. Oh, it's just a squiggle at this point. Jeez. Over n all over n minus 1. Okay, this is all in the square root, that's just my bad drawing. Okay, let's plug it in. So, what is the sum of x squared? A large number here. 5, 7, 7, 2. Oh, I'm going to run out of space. No. Minus, okay, sum of x, we have 641. What is 641 squared, someone? One oh eight eight one. Yes, concurred. Oh no, I don't have space. It's so frustrating. 1 over just like 11 all over n minus 1 10. Okay, I think let's just do one more step. So somebody quickly work out this one. 410881 divided by 11. Seems right. 3735 2. 0.82, apologies. Okay, divided that by 10. I think let's just do this one step, guys. Oh man, we're here, we might as well. Okay, what is this? So it's 57725 minus 37352.82 gives us 2037.18. What's the point? Okay, divide that by 10. Okay, mathematical trick, that just means you move the dot to the left once. So
now, remember to carry through that square root. The standard deviation is 45.14. And because we now know that the variance is equal to the standard deviation squared, the variance is 2037.22.